Now that we know the difference between similar and congruence, we're just going to focus on similar solids from now on. So we need to understand scale factors a little bit and how they apply to surface area and volume. I'm actually going to put a label in here. I'm going to say inches on this one and inches on this one. So if you were to tell me the scale factor between this shape on the left and this shape on the right, you would tell me it would be 2/3. But if I want to relate those to surface area, remember surface area, its labels were something inches squared, and volume would be something inches cubed. So if I ask you to set the scale factor of 2 inches over 3 inches, and you wanted to relate that to surface area, you would need to square this. The square goes to both parts, so 2 squared would now be 4 inches squared over 3 squared would be 9 inches squared. Now you'd be able to set your scale factor equal to your surface area. Likewise, if you want to do the same thing with volume, if I was still dealing with 2 inches and 3 inches and you wanted to set this scale factor equal to the volume, well, now you would need to cube it because volume is in terms of inches cubed. So 2 cubed would be 8 inches cubed. Oops, stopped writing again. 8 inches cubed over 3 cubed would be 27 inches cubed. We'll do a couple examples to hopefully make a little bit more sense as to what we're talking about here. So 2 examples. We'll look at this top one here. 2 similar cones have a radii of 10 millimeters and 15 millimeters. What is the ratio of the surface area of the small cone to the surface area of the large cone? Okay, so first things first, we want small over large. So I want 10 over 15. We can reduce that. 10 over 15, we can take out a 5 from each. So 10 divided by 5 would get me 2. 15 divided by 5 would get me 3. And I'm going to use my labels in here, millimeters and millimeters. And they want what is the ratio of the surface area to the small cone to the large cone. So if I want surface area, I need to get my labels in terms of something squared because surface area is squared. So we're going to square both of these. 2 squared is 4 millimeters squared. And then for your bottom, 3 squared is 9 millimeters squared. That would be the ratio that they're looking for. I got one more down here at the bottom. 2 similar prisms have surface areas of 98 square centimeters and 18 square centimeters. What is the ratio of the height of the large prism to the height of the small prism? So now I want the large over the small. So we want 98 centimeters squared over 18 centimeters squared. And they want just the ratio of the height. Well, the height is something centimeters. It's not squared, it's not cubed, it's nothing like that. It's just centimeters. So first things first, I would recommend simplifying 98 and 18. You can take out a 2 from each, and that will get you 49 centimeters squared over 9 centimeters squared. And then if I want to go backwards, if I want to just get this into centimeters, to undo something squared, now you square root everything. The square root of 49 is 7 centimeters over the square root of 9, which is 3 centimeters, which would be the ratio of your heights.